Hi, welcome to America Reads Fun Learning Activities. We're college students who create learning activities for kids. Our fun activities are focused on reading, writing, and math. Thank you for joining us to learn today. My name is Rebecca. Today we'll be learning about how to factor numbers. What is factoring? Factoring is like breaking down a large number into smaller numbers that, when you multiply them together, equal that larger number. This can be hard to understand abstractly, so let's try an activity. Say we have the number 24. What numbers can we multiply together to get 24? Maybe 2 and 12, 3 and 8, 4 and 6. You can also have all those pairs but flipped, like 6 and 4, 8 and 3, 12 and 2. You could also say, I guess, that you can multiply 1 and 24, or 24 and 1. What other combinations could we have? Well, we can break some of these down into smaller pairs. For example, we can turn 6 times 4 into 2 times 3 times 4, which equals 2 times 3 times 2 times 2. We could do the same thing to 3 by 8, where 3 times 8 equals 3 times 2 times 4, or 3 times 2 times 2 times 2. If you try this with the other two, you'll get the same numbers again. So what exactly is a factor? You can think of a factor as a number that this number 24 is divisible by. A factor pair of a big number is a pair of smaller numbers that multiply to the bigger number, like these. You can also find prime factors by breaking each factor down until it can't be divided anymore. Based on this definition, can you guess what it means for a number to be prime? A prime number is a number that cannot be divided by any whole number except itself and 1, which doesn't really count as a factor. Can you think of some examples of a prime number? 7's a good example. 13 too. You can't divide these numbers by any other number and expect to get a whole number as an answer. What about 9? Is that prime? Well, 9 is equal to 3 times 3, so it's not prime. A number that is not prime or has factors other than 1 in itself is called a composite number. Composite means that it's composed of or made of smaller parts. These smaller parts in this instance, say 9, would be the two numbers that are multiplied together, 3 and 3. Consider these numbers, 2, 3, and 5. Are these numbers prime or composite? I'll give you a minute to think about it. Can you divide them into a smaller number? 2 can only be divided by 1 and 2. So, by the definition of a prime number, it's prime. The same thing with 3. 3 is only divisible by 3 and 1. Finally, the same thing is true with 5. So they're all prime. These three numbers are very useful for determining if a bigger number is prime or composite. Here are 3 tips that you should remember when trying to factor a large number. An even number, one that ends in 2, 4, 6, 8, or 0, is divisible by 2. A number whose digits add to a number divisible by 3 is divisible by 3. A number ending in 0 or 5 is divisible by 5. Let's think of some examples of these. Some even numbers, 12, 36, 122. These are all even, so they can all be divided by 2. For the second tip, an example is 12. 1 plus 2 equals 3, and that's divisible by 3, so 12 is divisible by 3. Same thing with 36 and 123. Some examples for the last one. 25, 130, these are both divisible by 5. The last tip for factoring requires you to know that the only prime numbers below 10 are 2, 3, 5, and 7. If a number between 1 and 100 is not divisible by one of these 4 prime numbers, then it's prime. With this information, try to see if you can determine which of these numbers are prime and which are composite. I'll give you a moment to pause the video and write down what you think. Have you had time to figure them all out? Let's go through them real quick. 4 is divisible by 2, so it's composite. 16 is divisible by 2, or you could also say it's divisible by 4 or 8, which means it's composite as well. 39 is divisible by at least 3. 72 is divisible by 3 as well. 77 is divisible by 7. 95 is divisible by 5. And finally, 97 is not divisible by any of these numbers, so it's prime. Say we're given a number and we want to find all of the smallest or prime factors of that number. The easiest way to do this is to make a factor tree. What we can do is break up a number into factors and keep breaking up those factors until they're all prime. Let's take the number 18 for example. You can divide 18 into 6 and 3, and then you can divide 6 into 3 and 2. 3 and 2 are both primes, so you found all the prime factors of 18. You can take multiple different paths to break down a number using a factor tree. For example, you could instead say 18 is equal to 9 times 2, and 9 is equal to 3 times 3. Either way, you end up with the same number of the same factors. Try using a factor tree to find all the prime factors of these numbers. I'll give you a moment to pause the video. Your factor trees should look something like this. If you divided them a little bit differently, that's okay. As long as the final prime factors are the same, that means that you've done it right. Now let's say we want to find all the factor pairs of a number. An easy way to do this is to draw rainbows. Really. Say we have the number 24. We can find all the factor pairs by starting low and working up. We'll start at 2. 24 is divisible by 2, and 24 divided by 2 is 12. We can write both these numbers on the end of a strand of a rainbow to connect them, letting us know that they're factor pairs. We can move up to 3. Is 24 divisible by 3? Yeah, 24 divided by 3 is 8, so we can draw another strand of the rainbow connecting 3 and 8. Next we'll try 4. 24 is divisible by 4, and it gives you 6. So once again, we can draw a strand connecting the factor pairs 4 and 6. Is 24 divisible by 5? No, so we don't include that on our rainbow. Is 24 divisible by 6? Yes, it is, but we already wrote that down. Since we've passed to the other side of the factor pairs, that means that we found all the factor pairs of 24. Try finding all the factor pairs of these numbers using a factor rainbow. I'll give you a moment to pause the video. Your factor rainbows should look a little something like this. Okay, so now we know how to factor. So what? When will this be useful? Let's try a real-world example. Say you just made 24 cookies and you want to share it with your friends and family. How many different ways can you equally divide these cookies among people? You can solve this using factor pairs. Now if you share with 2 close friends, you and them should each end up with 8 cookies. Say your older sibling comes along and asks for some too. If you divide this evenly now, you'll see that everyone will get 6 cookies each. Your 2 younger siblings come along and ask for some as well. If you divide the cookies evenly, you'll see that each person will get 4. If your parents come along and ask for some too, each person will get 3. Finally, if all of your grandparents come along and ask for some cookies too, you'll have a total of 12 people, and each person would only get 2 cookies. That's all for today. Thanks for learning with us. I hope you come back to learn some more. Please comment if you have any questions, like and subscribe to our channel, and we'll be back with more videos. Bye!